Today we will learn and continue about the time series forecasting method.
Let's discuss another method in time series forecasting that we call it the associative forecasting. In time series forecasting that we already learned before, this type of forecasting only use the data that is coming from the past. It's mean the relationship between or the correlation between the data we not discuss at all. So it's kind of like a black box. So we only rely on the trend of the data in the past and projected those trends to the future. But the associative model is used to show or predict the relationship between the data or variable or factor in this case. It can be two, it can be more. The factor that being predicted, the factor that the equation solve in this case is called the dependent variable. And this is used when change in one or more independent variable can be used to predict the change in dependent variable. So there is independent variable, or we call it this is a predictor, and dependent variable. This is the variable that we should predict. This is the formula, one formula in associative forecasting, that is linear regression, where y in here is this is the predicted variable, and x in this case is independent variable, so we can call it this is as a predictor. So y is equal to constant a plus b, this is a slope of the regression line, multiplied by independent variable x. So this should be y is predicted, and x should be the predictor. With the least square method, consider this situation, in this figure. So this star, many star in here, and they have many star in here, is actual observation of y value. So this is the actual observation of y. And when we draw the trend line, the blue one here is the trend line. When we draw this one, there is a deviation or error between the trend line and the actual observation of our predicted value. So there is deviation 1, deviation 2, 3, and so on and so on. So what we should do is, to make a trend line, a line that minimize sum up, sum of all of this deviation. So deviation 1 plus 2 plus 3 plus 4 and so on. We sum all of this, and then we create a trend line that minimize those sum. So we got, based on this method, we have the formula to get the b and a constant. So the constanta to calculate b and a is represented in here. In forecasting, we need to judge which forecast method that is best to use. Here we use the error measurement. The first error measurement that we can use, we call it the mean absolute deviation. That is the formula of this mean absolute deviation is actual minus forecast divided by n. And this number 2 of the error measurement is, we call it MSE. This is simply the same with the MAD. This is based on the square root. This is because based on this the square of the forecast error sums, and we sum up the forecast error and square of the forecast error divided by n. What is forecast error? Forecast error is actually equal to, so let me see in here, forecast error is equal to actual minus forecast. So actually the MAD and MSE is similar, where the in MAD the forecast error, this is actually forecast error. Yeah. We make it into the absolute form, and in MSE we make it into the square form. Both of them make the result of the forecast error is into positive value. So thank you so much for joining me in discussing about the associative forecasting. I hope it complements the time series forecasting method that we already learned before. See you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.